Apparently we're into a part 2. So often when I go to autofocus, I hit this blaring red button and stop my video. Anyways, it was not a bad place to stop. It was a little bit short of where I would have liked to stop. The next problems are not good on tests. It would be wrong on problem 26 to say x plus 3 squared equals x squared plus 3 squared. The rule that allows us to do that, if the problem said x times 3 quantity squared, I could say that's x squared times 3 squared. The rules that we learned for clearing the exponents to clear the parentheses applied when there was straight multiplication, didn't apply when there's addition or subtraction inside of parentheses. The way that I like to teach these is just to rewrite the problem so that it doesn't have the exponent, and then just do FOIL. There's a formula way to do it, but why learn a formula when I can just rewrite the problem in FOIL? So for this problem, 26, I'm going to rewrite it, and now I'm going to do firsts, which are x times x, which is x squared. Outers are x times 3, which I can write as a positive 3x. Inners, which are positive 3 times x, which is another positive 3x. Lasts are positive 3 times positive 3, which is a positive 9. Normally, when I FOIL, the outers and the inners can combine, unless the problem's not written in standard order or there's other unlesses, but normally that happens. So if I would have just squared the x and squared the 3, I would have written x squared plus 9, and I would have missed the middle term. So when there's addition between numbers and letters, when there's binomials in parentheses, we need to rewrite it and FOIL. Let's do 27 together. The quantity 3x minus 2 squared can be written as 3x minus 2 times 3x minus 2, and I'll FOIL. Firsts are 3x times 3x, which is 9x squared. Should be writing equals because of what I'm writing is equal to the line above it. Then I get 3x times minus 2, which is minus 6x. Then I get minus 2 times 3x, which is minus 6x. Then I get minus 2 times minus 2 is positive 4. The minus 6x, they have the same sign. The numbers don't cancel. You add the numbers and keep them negative. So for 27, the answer is going to be 9x squared minus 12x plus 4. The next multiplication is ugly. I'm multiplying a binomial times a trinomial. And the nicest way to multiply a binomial times a trinomial is to write the trinomial like in problem 30 above the binomial. I have two parentheses next to each other, so this is a times problem. And now I'm going to do kind of multiplication like you might have learned in grade school. I'm going to go minus 2 times each of the items above it and 3x times each of the items above it. So first minus 2 times positive 3, that will give me a minus 6. Then minus 2 times positive 5x, that will give me a minus 10x. Minus 2 times positive x squared is going to be a minus 2x squared. And then I'll start with the 3x, and I'm going to indent. So I'm going to go 3x times 3. It's going to cause me to multiply the 3's and leave the x. I get a positive 9x. And then 3x times 5x, I multiply the 3 and 5 and get a positive 15. And x times x is x squared. And then 3x times x squared is really 3x times 1x squared. I do 3 times 1 and get 3. And I take that x that has an exponent of 1, add it to the exponent of 2, and get a 3x cubed. Now I'm going to bring down the negative 6. I'm going to bring down the 3x cubed. And I'm going to combine. If the numbers in front of the variables have the same sign, I add. If they have opposite signs, I subtract. Here, the like terms of negative 10x and positive 9x combine to be a negative 1x. And negative 2x squared plus 15x squared combines to be 13x squared. This is where I'm going to leave my answer, but I don't have to have the 1 in front of that negative 1x. I could just write minus x. Let's do 29 together. So 29 is multiplying a binomial times a trinomial. I'm going to write the trinomial on top of the binomial, and I'm going to sneak some 1s in front of some x's that might make my life easier when I multiply. So I wrote my trinomial on top, binomial under it. And now I'm going to go negative 4 times negative 2 and get positive 8. Maybe I'll write that plus sign. Negative 4 times positive 1x and get negative 4x. Didn't really need the plus sign there. I don't know why I wrote it. And then negative 4 times positive 3x squared. I multiply the negative 4 and the 3 and get negative 12x squared. And now 1x times negative 2. I multiply the 1 and negative 2 and get negative 2. I leave the x. And then 1x times 1x. I multiply the 1s and get a positive 1. I multiply the x's by adding the exponents and get an x squared. Forgot my horizontal line here. And then 1x times 3x squared. I multiply the 1 and 3 and get 3. I add the exponent from the x squared of 2 with the exponent of 1 from the 1x, and 2 plus 1 gives me an exponent of 3. I'm going to bring down the 8, and I am going to need that positive sign because I need signs between each of my terms, and that's a positive number. The x's are both negative. I'm going to add the numbers and keep them negative. The x squareds have opposite signs. I'm going to subtract and get the negative sign, and I'm going to bring down the 3x cubed. Not checking, so there's definitely room for making errors that I don't care to make, but I could do that. So the next few problems give me function notation, and function notation's not necessarily my friend, but yeah, it is what it is. Let me just pull this sheet up here that I have. So if a problem gives me a function named f of x and a function named g of x, and in the instructions it asks me to multiply f of x times g of x, well, that's really that's just saying multiply, and when I go to multiply, I'm going to create two parentheses, just like when I went to add f of x plus g of x or subtract f of x and g of x. So I'm asked to multiply two functions. I'm going to create two parentheses. I don't have the need to put a sign between. When I did f of x plus g of x, when I did two parentheses, I put a plus sign between. When I did f of x minus g of x, after I created the two parentheses, I put a minus sign between. But this is multiplication. I don't need a sign between. Inside my parentheses, I need to plug what the functions are equal to. In this particular problem, the f of x is 3x plus 6, and the g of x is 2x plus 5. So this question, find f of x times g of x when it gives me the functions, is just asking me to FOIL 3x plus 6 and 2x plus 5. And I wrote it vertically because it wouldn't fit horizontally, did the foiling, and combined like terms. The next problem wanted me to find f of 4 times g of 7. Create my two parentheses because of the times, And in the first parentheses, instead of putting the regular f function in, I'm going to put the f function in but change the x to 4. And in the second parentheses, instead of putting the regular g function in, I'm going to put the g function in but change the x to 7. Then it's just an order of operations and my answer is just going to be a number. My first parentheses, I'll do the multiplication first, then the addition. My second parentheses, I'll do the multiplication first, then the addition. And then I'll believe the number that I got here. Hey, what's going on here? Oh, there's a mistake on this. This should have, oh, it's a good thing that I did this. It should have a 5 here. That should be a 19. This is correct, that's not correct. I've scanned these documents a few times, but it's never going to get all the mistakes until you teach out of it a few times. So, problems 35 and 36 give us exactly these questions. They give us a function called f of x, a function called g of x, and in part A, they asked me to find f of x times g of x. To find f of x times g of x in problem 36a, I'm going to create two parentheses with no sign between because multiplication doesn't need a sign. In the first parentheses, I'm plugging what f of x is equal to, which is 2x plus 8. In the second parentheses, I'm plugging what g of x is equal to, which is 4x minus 3. And now I'm going to FOIL. I'm going to go 2x times 4x, which is going to be 8x squared. I'm going to do 2x times minus 3, which is going to be minus 6x. Should be writing equal sign somewheres. Then I'm going to do 8 times 4x, which is positive 32x. Then 8 times negative 3, which is negative 24. And then generally when we FOIL, the outers and the inners can be combined. The minus 6 plus 32 gives me a 26. And for an answer to part A, I'd say it's 8x squared plus 26x minus 24. Part B wants me to find f of 7, or f evaluated at 7, times g evaluated at 4. Create my two parentheses from the multiplication, and in the first parentheses, instead of putting 2x plus 8, put 2 times 7 plus 8. And the second parentheses, instead of doing 4x minus 3, do 4 times 4 minus 3. And then just do my orders of operations. My first parentheses is going to turn into 14 plus 8. My second parentheses is going to turn into 16 minus 3. That's 22 times 13. My answer to part B is going to be 286. So your 35 should work the same. Let's do 36 together, maybe because it's a little bit different. All right, let's do, oh, I flip-flopped the order. Let's do 33. I don't know what happened there. My sheets got out of order. Not such a big deal. 33 wants me to find f of x times g of x. Two parentheses. In the first parentheses, write what f of x is equal to. In this problem, I'm told it equals to 5x. Second parentheses, write what g of x is equal to. In this problem, I'm told it equals to 4x minus 3. Now I'm not going to FOIL, I'm just going to distribute to clear the parentheses. I'm going to go 5x times 4x and 5x times minus 3. 5x times 4x, I multiply the 5 and 4 and get 20. I add the exponents on the x's. 5x times minus 3, I get a minus 15 and I leave the x. The answer to 33a is going to be 20x squared minus 15x. For 33b, to do f of 4 times g of 5, I'm going to create two parentheses. And instead of plugging 5x into the first parentheses, I'm going to plug 5 times 4. I'm going to change the x to 4. And in the second parentheses, instead of putting 4x minus 3, I'm going to do 4 times 5 minus 3, changing the x to 5. I can separate the parentheses separately. The first parenthesis simplifies to 20. Orders of operations in the second parentheses, I do the 4 times 5 first, and then subtract 3. I think that's 340, but I don't want to write down the wrong answer. I'm probably sure I've written down a bunch of wrong answers. I'm trying to make the videos more bearable and not pausing a million times to check. We have a few more kind of odd problems where I'm asked questions about functions and I'm given tables and graphs. It's not particularly hard. I'll show you what I mean. Problem 37 gives me a table, and in the top of the table it says these are values of x, and in the middle row it says these are the values when you evaluate f at that number for value of x, and in the bottom it says these are the values when you evaluate g. For problem 37a, it asks me to find f of 3 times g of 4. I'm going to make 2 parentheses for my times. And for f of 3, I go to the f row and I go to the x row. I need x equal to 3. And I need to find what f is equal to. F is going to be equal to, f of 3 is going to be equal to 0. The next one wants me to find g of 4, so I'll find the g and the 4, and where they intersect, that's what g of 4 is going to be equal to. G of 4 is going to be equal to 0. I have the time sign between because this is a times problem. This is going to be 0 times 0, which is 0. In part B, I'm going to put a plus sign between because there's a plus sign between. Parentheses to the left of the plus sign, parentheses to the right of the plus sign. Turns out that parentheses are almost never necessary for plus. First parentheses, I need f evaluated at -2. So I find the -2 in the x row, go down to the f of x, and change that to a -5. And then g of 1, I go to the g row, find -1 in the x row, and go down and get 15. So this is just -5 plus 15, which is just 10. I could have did -5 plus 15 and put all my parentheses in. They weren't necessary. With or without the parentheses, -5 plus 15, having them both in a parentheses, having neither in a parentheses, having one of them in a parentheses, this is all equal to 10. Part C, I'm going to make a fraction because I see a fraction. In the numerator, I'm going to replace f of 0, and f of 0 I'm going to replace with 12. In the denominator, I'm going to change g of -3, and g of -3 I'm going to replace with a -4. I go to the -3 for the x, down to the g value, and get -4. So that's just 12 over -4, which is -3. For D, I'm going to put a minus sign. Usually I need parentheses with minuses. I probably really don't need them here because I'm only putting a single number in. For the G of 2, I'm going to plug in 9. For the F of -1, I'm going to plug in 6. So this is just parentheses 9 minus parentheses 6 are 3. And I could drop both parentheses without doing any modification. First parentheses doesn't have a sign in it, and the second parentheses doesn't have like a binomial, so I can just drop the parentheses. Regardless, the answer is just going to be 3. That's one newish kind of problem. The last newish kind of problem, instead of giving me a table to get the function values, I give you a picture. And this is a graph of the function f of x. I labeled some points. For what it's worth, the points that are labeled are 5, 3, 1, -5, 0, 12, negative 2, negative 32, and 9, negative 21. 4a wants me to find f of 0 plus f of 9. I'm going to put a plus sign. I don't really need the parentheses. F of 0, the 0 stands for an x, and it wants me to find the y. So this first f of 0 is calling out that point, and that's really negative 12. I flubbed the sign there. That should be 0, negative 12. Just couldn't see the negative because it's right on the axes. So in place of the f of 0, I'm going to plug negative 12. And in place of f of 9, I'm going to plug negative 21, either from there or there. And this I could do on my calculator if I couldn't do it in my head. For part B, f of 1 is going to be negative 5. F of 5 is going to be 3. I put a minus sign between, put the numbers in parentheses, but I probably really don't need the parentheses, but it's okay to have them. I'm going to get negative 8. I only have one variable here because I only have one graph. I can't call it two different names. And lastly, it's a times f of negative 2 times f of 5. I make two parentheses with no signs between. For f of negative 2, I'm going to write negative 32. For f of 5, I'm going to write 3. And because this is a multiplication problem, I'm just going to multiply them. All right, so that wasn't so bad. That's only 40 minutes between the two parts, maybe even less than that. So, wow, that was nice. Not checking speeds up the process quite a bit. Hopefully it wasn't too fast.